motion in a straight line. For example, one particle traveling along horizontal path. This is also called motion in a straight line. Similarly, one particle traveling vertically upward. This also belongs to straight path. Similarly, one particle coming downward. This also straight line. So these are all belongs to motion of the particle in a straight line. So before going to this, just we are discussing about kinematics and dynamics. These are two branches in our physics. So first I am discussing about kinematics. What is kinematics? Kinematics purely explains the motion of the system. Kinematics purely explains the motion of the system or a particle. In this case, we are not considering how much force exerted on the body for getting that motion. What is the mass of the body? Like that, all things not considering. Just we are discussing about only its motion. For that motion, what are the causes? We are not discussing. So purely explains the motion of the system is called kinematics. Similarly, what about dynamics? In the dynamics, we are considering total mass of the system, how much force exerted on the system due to that particular velocity it had got and acceleration got, like that things clearly we are discussing. Everything we are discussing. How much force exerted, what is the mass of the system, everything considering. So that is called dynamics. So these two are the branches in our physics. So in this, motion in a straight line, motion of the system we are taking. It is moving along straight path. So that is called one dimension motion. This is also called motion in a straight line, also called one dimension motion. So in this, first we are discussing about frame of reference. Frame of reference. We are having two types of frame of reference. One is inertial frame of reference. One is inertial frame of reference, and another one is non-inertial frame of reference. Non-inertial frame of reference. So what is inertial frame of reference? It explains about acceleration is zero. Simply, which system acceleration is zero, that belongs to inertial frame of reference. Acceleration zero means, for example, one system is at rest, acceleration zero. Similarly, one system is moving with uniform velocity. In that case also acceleration zero. So these two belongs to inertial frame of reference. In the inertial frame of reference, we are getting two conditions, rest condition and uniform velocity condition. Uniform velocity. Similarly, non-inertial frame of reference. In this case, acceleration is not zero. That means it is having some acceleration. System having some acceleration. So that is called non-inertial frame of reference. For example, one bus is traveling with a uniform velocity. So acceleration is zero. That goes to inertial frame of reference. Similarly, one bus is at rest. In that, one passenger sitting. That system also belongs to inertial frame of reference, because in that acceleration is zero. Similarly, one bus is moving with some uniform acceleration. In that one passenger is sitting. That system I am taking. That belongs to non-inertial frame of reference. That belongs to non-inertial frame of reference. Which frame of reference is having some acceleration? That is called non-inertial frame of reference. Okay, next topic we are going to distance. What is the definition to distance? For example, one particle is traveling from A point to B point along this path. Different paths it is traveling. So, length of the path is called distance. What is the distance? Length of the path. Length of the path is called distance. What is the SI unit for distance? Its SI unit is meter. What is the CGS unit? Its CGS unit is centimeter. This is about distance. That is about distance.